Okay, so in this problem here, there's a bunch of things to be careful of. We're first told the radius is 40 centimeters and the height is 100 centimeters. And then water flows out of the tap at the bottom directly proportional to the square root of the depth of the water. All right, so that there tells me the water flows out. So that tells me dV dt is leaving, flows out. That is proportional to the depth of the water, which is the square root of the depth of the water. That is A part here, this scenario here. Now, going to B part, there's a lot of information we have to keep track of. After heavy rainfall, the tank is filled. So when t equals 0, I know that the height is filled 100 centimeters. But it also says meters cubed. So we have to make sure all our units are actually in meters. So my height is 1 meter. My radius here, is going to be 0.4 meters. So now moving from there, we want to apply the chain rule and the formula for the volume of the cylinder to show that this is true. Well, I know that the volume of a cylinder is V is equal to pi r squared h. And for this particular can, the r is fixed. It is 0.4. And so I can say definitively that V is equal to pi 0.4 squared h. 0.4 squared, well, you can do it as decimals, but if you want to know what I was thinking about how they got the answer in the book, that's 4/10, which then 4/10 is simply 2/5. Square that, you get 4 over 25 pi h and v. Now, so there is our formula for volume in terms of our cylinder. But we're asked to come up with this scenario here is what we have to come up with. So I know also that the chain rule says that dV dt is going to be equal to dV dH times dH dt. And so now, if I take a look at here, I can find dH dt from here. And so if I do dH dt, dV dH, not dV, dV dH, that's what I've been meaning to say, dV dH is equal to 4 pi over 25, because the h, bring the 1 down and subtract, that just goes away. And so I know that dV dt is equal to dV dH times dH dt. Okay? So that is showing this part. Then it says, hence write your part, write this answer. We need to write a term, an equation in terms of h and t. Well, recall from part A that dV dt is also equal to negative x square root h. I mean negative k square root h. So that means negative k h to the 1/2 is dV dt is the same. This is the same as that, and so it becomes this is equal to 4 pi over 25 dH dt. And I'm looking for an equation that involves h and t. Well, I look around here and I have to separate my variables. So I'm going to bring this over. So negative k 25 over 4 pi times dt is equal to h to the negative 1/2 dH, and of course I'm going to integrate both of them, so that's good, that's proper. when I do the left side here, I get negative 25k over 4 pi t plus some constant c is equal to, well, I add 1 to my exponent and I multiply by the reciprocal plus a constant, but that's just that constant there. And so I have h and c. I need to find this value for c. If you recall, we know that when t equals 0, the height was 1. So when the t is equal to 0, the height was 1 meter. And so I plug in 0, so that's 0c is equal to 2 times 1, so c is equal to 2. So I have negative 25k over 4 pi t plus 2 is equal to 2h to the 1/2. Now, to find the k value, the other information that I know is at 10 minutes, it has dropped 264 centimeters. So I know that at t is equal to 10, h is 64 centimeters, which is 0.64 meters, because I have to do it in meters. Plugging these values in, the other thing I'm going to do is this whole thing here is just a constant. So I'm going to just let a be negative 25k over 4 pi. Like a constant's a constant's a constant. I don't need to know the actual value of k because it doesn't ask me for that. So then I can say that a times my value of 10 plus 2 is equal to 2. My h is 0.64 to the 1/2. Well, 10a is equal to 2. This here is 0.8, subtracting the 2 over from here, which that's 1.6 minus 2. And so a will be 1.6 minus 2, dividing it by 10. A will be negative 0.04. I'm plugging it back in, so then I know that negative 0.04 times t, because here's my a value, which I figured out, t plus 2 is equal to 2h to the 1/2. I'm solving for h, so I'm going to divide by 2, so negative 0.02t plus 1 is equal to h to the 1/2. And h as a function of t is going to be 1 minus 0.02t squared. And so this is h as a function of t, which is what the question was asking for way back when. And then finally, C part says, predict how long will it take for the tank to empty. That means I want the h to be 0. So I go back to my equation here. I know I want h to be 0. So I have 1 minus 0.02t squared. I can get rid of the squared because and then I just solve for my value. I'm going to 0.02t is equal to 1. T will be 1 over 0.02, which I know if I put my calculator is 50 minutes. Quite an involved question. A lot of calculus bringing even in the chain rule and related rates a little bit. Quite challenging.